All right, class, let's take a look at this final example. It says Bill Gates, the president and CEO of Microsoft, wanted to know if his pay is competitive with Google's. He decided to interview 49 of Google's thousands of employees. When he interviews the 49, he finds the average salary to be $49,298, with a standard deviation of $9,865. Create a 95% confidence interval to help Bill Gates approximate the average for all employees working for Google. All right, so we're going to take all the information it gives us, we're going to look at it, and then we're going to transpose it onto a doc. So, first off, we know our sample size. It's going to be 49. It's how many people we interviewed. We know that when we did interview those 49 people, we got an average of 49,298. It also gave us a standard deviation of 9,865, and we know our confidence level is going to be 95%. This gives us the 4 pieces of information we need to solve. So let's go over to our Google Doc. All right, the first thing you should notice is that I wrote down my n, my average. This would have an x bar over it if you could make an x bar inside of Google Docs. Our sigma, which is our standard deviation, and our confidence level, or C, which is 0.95 or 95%. Right, well, we know that our confidence levels are all associated with a critical value, and our critical value is going to be a constant number. So we can actually go back to our notes that we took earlier on that to find out exactly what that number will be. So we're going to scroll up a bit, and right here. Okay, so we know for 80%, our confidence level will be positive or negative 1.28. For 90%, 1.645. For 95%, 1.96. And for 99%, 2.575. Well, we are looking at 95%, so we're going to use 1.96 as our critical value. Okay, 1.9. Sorry, let's do that. 1.96. All right, we got our critical value. In order to find our margin of error, we need our critical value and our standard error. Our standard error we get by taking our standard deviation and dividing it by the square root of our n. So let's go ahead and punch that in. Let's make a fraction. On the top, we're going to have our standard deviation, which is 9,865. And down below, we're going to have the square root of our n, which is 49. We know that the square root of 49 is just going to be 7. So let's rewrite this again as 9,865 divided by the square root of 49, which we said was 7. We can actually do that on our calculator. 9,865 divided by 7 does give us approximately, let's say, $1,409. So we'll write that out here. Equals $1,409. All right, once we get this number, this is going to be our standard error. We already know what our critical value is, so we can plug these in now. So our critical value was 1.96. We're going to multiply that by 1409. And we are going to find that equal to $2,761.64. Let's round that to 2762. All right, and we now have our margin of error. We're going to go ahead and take this margin of error, and we're going to both add it and subtract it from our average. So we're going to take 49298 and subtract from it 2762. And we are going to find that answer to be $46,536. And this is going to be our lower value on our interval. Let's see what our upper value would be. So again, we're going to start off with the same average. That's 49298. And now we're going to add to it our 2762. Let's find that again. So 49298 plus 2762 gives us $52,060. And we now have our upper and lower levels of our interval. Remember, we're going to put our lower level here on the left. So 46536. And we're going to put our upper level 52060 on the right. What this tells us is that our population average, or the average for all employees at Google, is going to be between $46,536 and $52,060. Let's go ahead and write that out. We can be 95% confident that the average salary for all of Google's workers will fall between $46,536 and $52,060. And that is going to be our answer, as well as finishing up this video. Thanks, guys.